Okay, so hello everyone. It's the fourth day of ours with the leetcode daily until we get a job. So let's start doing the questions for today. Today we have the stack, and we will be doing these four questions. These first four questions, okay, and these three will be attempting tomorrow. So let's start with the first question. That is the valid parenthesis. That's a pretty straightforward question where we are given with the input string and we have to check if it's a valid parenthesis group of parentheses or not. Like if for every opening there must be a closing and they must be aligned in order. So there are three kinds of bracket here. So what we can do is we can simply have a stack, and we can start enumerating this. Not int, must be character, char I of s. For every of it we have to check if it is a opening bracket, means if it's a opening round or it's a opening square or it's a opening curly. Then we just need to do what is that we just need to simply push it in the stack. Okay, and if it is not an opening bracket and the stack is empty, like it's a closing bracket and the stack is empty, then there is no opening for that clause before it, then it's a invalid parenthesis, right? So it will return false simply. And if the stack is not empty, then what we can do is, if it is a closing round bracket, and then the top of the stack must also be a round bracket that is opened. Okay, and stack dot top is not equal to a opening round, or you can just copy the same thing. Yeah, then return false and just replace these brackets. Okay, and after that we can put a pop here. Okay, and we can just return, like at the end of it, if the stack is empty then it's true, and if it's not then it's not a valid parenthesis. We'll just try submitting it. Okay man, that's a C, not I. Sorry for this. Oh my goodness, not 2 equals. This silly mistake I must have first time run it simply, but no worries, it's 100%. So we can go to the next question. Here we have the min stack, and what we need to do is design a stack that support push pull pop, retrieving the minimum element in constant time. So that means that we have to take the minimum element out in constant time. That means we have to keep the track of that minimum element every time. Okay, we have to keep the track of minimum element every time. So what we can do here is that there's no constraint for space, right? Okay, so let's do one thing. Let's take two vectors, vector int v and min v. Okay, while pushing, what we can do is, so what we can do is we have to keep the minimum element at the top, right? So if the vector is empty, if the minimum vector is empty, minimum vector will do one thing: the back element, means the last element of the min v, should be the minimum element of this input. Okay, so if minv dot empty, it's empty, then we will just simply minv dot push back this val. Else we will do what? If it's not empty and this value is less or equal to minv dot back, then minv dot push back val, otherwise not, right? And in the v we always need to push it, push the element. Okay, now next thing what we can do is in the pop is simply what, retrieving, like putting out the last element, right? And if but what if that last element of v is also the minimum element? Like we are just simply doing what, v dot pop back, but what if this element is also the minimum element of min v? Min v is based on v. There must be no element in min v which is not in v. So we have to put a condition here that if v dot back is equal to min v dot back, then we also need to pop back from min v. Okay, top is nothing, just like returning the element of this pop, whatever is there in the pop, we just have to return it. So in the top we just will return min v dot back. Okay, getting min is simple now, that we will just return min v dot back, and I guess this is it. This should work. Oh, it's somewhere is mon v, sorry for that. Yeah, running it should do. Okay, that's correct. Yeah, it's good. Okay, so evaluate the reverse Polish notation. Yeah, it's simple if we look at it, that this symbol is will be applicable for the last two digits, and we will apply this symbol to these digits. The result will be 3, then 3 and this 3 will apply it on this symbol, so 3 into 3, that will be 9. So what we'll do is 4 put in stack, 13 put in stack, 5 put in stack. Next is a symbol. If it's a symbol, then take the last two elements 5 and 13, apply this operation to it, 13 over 5, 13 by 5. Okay, it will result in some digit, so that digit will be in the what we say stack. So if this plus will be applicable on this digit and this digit, 13 by 5 plus 4. Okay, that's how we need to do. That's a simple one actually. So we will form a stack of integers as s, and what we'll be doing is we'll be enumerating this vector of strings. So there'll be string. Okay, that will be character. No, it can be a string. Let's put auto. Auto of tokens, and what we will be doing with it is that if the token is equal to plus sign, then what we can do is int val1 is stoi stack dot top, that will be val2 actually, and into val1 will be string to integer stk dot top. We will stk dot pop here and stk dot pop here, and stk dot push what, val1 plus val2. uh, shouldn't we convert this into a string again? Shouldn't we convert this into a string again? I think we should be doing it, but that's fine, I guess, not a problem. Wait, we are pushing the ultimately. Okay, we don't need to do even this. We can just push the integers only in the stack, right? That will work. Yeah, okay, that will work. Else if a is equal to a minus sign, then we'll be doing something similar to this, just putting a minus here. Else if it's a multiplication sign, that a star or asterisk, we can do the similar thing. And else if a is a division sign or a slash, then we will be doing this. And else what we can do is stk dot push stoia, right? This should be fine, I guess. And return stk dot top. This should do the thing. If a is plus this, okay. Okay. For every this, we need to replace it with this. Replace all. I did the job right. Yeah, I guess. STK. Okay, we put it as. Sorry for this. How can I do this, man? Yeah, it should run now. Yes, correct. And yeah, it's done. So the last question is, given n pairs of parentheses, the value of n is given, that's an integer value, and we need to write the function to generate all combinations of well-formed parentheses. Valid parentheses, we need to find whatever possible combination of valid parentheses is there with this as the opening or closing count. Okay, 3 opening and 3 closing. What we can do is all of these combinations. So yeah, somehow we can look at that and see that this is somehow a backtracking problem, that wherever we have to find combinations and all possible combination, that problem will somehow comes to the backtracking. Okay, we have to make one combination, then backtrack, then some other combination, then backtrack, just like that. So yeah, we have to do it that way. Let's make a vector of string which will be the answer. Okay, and an empty string, right? So we will just call a function here. There will be an empty string, number of opening brackets in it, number of closing brackets in it, the value of n, the value of n, yeah, the value of n, and the answer here. Okay, and we will just return the answer. Now in the helper function, this will be a void, and there will be a string and temp, we can say. There will be int open, int close, int n, and vector of string and answer. Okay, what we will be doing in this is that if the number of open bracket, see, it will be a recursive function, backtracking is there. So in the recursive function we know that there's firstly the stopping condition. If open bracket is equal to n and close bracket is equal to n, then that's a stopping condition, right? So what we can do is we can just push back, or what we'll say that we will just push back answer dot push back the temp in it and return, right? Now if o is if o is less than n, means we do not have enough opening brackets up to now, then what we will do is temp dot push back an opening bracket and what we can do is we will push an opening bracket into it, and after pushing that opening bracket, or we can say is not this, but it's not a vector, obviously it's a string, so we need to concatenate, not push back. And after that we need to call the recursive function for temp. We can do the same thing here, I guess. Yeah, let's try this fancy stuff, isn't it? Okay, open is now o plus 1, close is the same, and n is the same, answer is the same. Now in the second condition, for the close brackets, close can never be greater than open, so if close is less than open, then only we will push, okay, the closed. Because if close is greater than open, that means there is one missing opening bracket for one closing bracket, at least one, so that will make it invalid. So we will call this recursive function as temp plus closing bracket o c plus 1 and an answer. Yeah, I guess this should work. And this is a stopping condition where we need to stop is that both are equal to n. Okay, let's try this. Helper temp plus, what happened here, string and result, string and result. This is fine, I guess. Temp plus, first is the string only, right? So how can we do it? What is I mean, how can it be? It should be fine. It should be fine. Oh wait, value reference to type basic string cannot bind to temporary of type basic string. Non-constant value L value reference to time means this is value by reference. So if we remove this, then it can bind to it, right? Okay, I think there was a binding problem here because it was referenced by value and we were adding it to it, concatenating to it. It doesn't work that way. Maybe that was the problem, I'm not sure of, but otherwise it's all fine. Okay, it's a helper function. I'm so confused with these namings because I mostly take two names for these helper functions, what is helper and what is solve, and I like usually confusion between them and do these kind of mistakes. So yeah, it's done. So okay, we're done with all the 4 questions of today that we decided, and yeah, here are the 4 questions. tomorrow we'll do these three and our stack will be done then. One hard and two medium. I guess that is fine. So yeah, how much time we took is just 20 minutes, because yeah, stack is a basically obviously not a very typical topic, and I have already don't you guys think that I am doing these all questions first time. I have did these questions earlier also, but I am just I'm redoing all of it because I've done it a long time ago and they are in my mind but they are faded, so I'm just practicing it again so that it's all in my mind at this time, and I'm doing daily to have the consistency up for me. Okay, because I was having a problem continuing the things which I start. I was inconsistent. I started a topic and does not finish it. It happened to me a lot of times. So this time I had this idea that let's try this way that a lot of people do it, that they try to upload it on YouTube or like somehow document it so that they can handle this thing. They can be consistent with it because they know that they have to post a video daily, even if nobody is seeing it. Like my videos don't have any views, but I know that I'm posting it. I have to post daily, so for that purpose only I need to do questions daily. So that helped me a lot, and I guess yeah, it's going good up to now. It's our fourth day and we are doing good. So that's all for today, and it's a 21 minutes video, 22 minutes video, and we did the questions in about 20 minutes, I guess, maybe. So that's good, and that'll be it for today.